Wow, the frame that was right there was crazy. Okay. So yeah, so we got a lot to do. Wait, hold on. So I should be able to add a video capture device. Add existing. I don't even know if that's right. Oh, yeah. Okay. So let's see here. We want to make it kind of more like that. Oh, wait. Okay. So what do we have? We have the bottom plate. Bottom plate. The 4 pillars. The gear. The brackets. Top gear. The top plate. This would probably go like that. There. This is the motor mount. And then the flywheels. And the only part that's really missing is the solenoid holder, which is being printed right now. So yeah, so let's just get to it. I have a document, actually, called assembly.md that tells me what I need to do. So the first thing I need to do is get a screwdriver. Okay, I'm going to move this up just slightly. Let's see, is that... Okay. So let's do this. So I'm going to be using M2 by 10 self-tapping screws. So we're just going to see how this goes with the first one. This is basically totally redesigned. So, you know, whenever you redesign something, I mean, most of it is exactly the same, but, you know, there's small changes, and I'm not sure I know I like all of the changes. So one of the changes here that happened was, oh shit. Wait, also I want to check that I'm actually on live, because I mean, it says I am, but just go to YouTube. It should be red up here, right? Okay, we're good. All right. So, okay, so yeah, so one of the changes that was made during this redesign was before these small pillars had small indents in the bottom plate so that you could align them. But what I found though is that since the face that the first layer, basically the way the printer orients this is from this side is at the bottom, that then these slight indents, they either need supports, or if you don't have supports, it gets all wiry and it gets very hard to take them off. You kind of have to cut them off. So I figured, okay, maybe since they're so small, it won't be that hard to get this in. But, and the other thing is, that I didn't think about until now is the reason why you can do something like this for a small part like these pillars is that you're not going to be constantly taking them on and off. But whereas the gear, so later on when we finish this in the assembly, this no longer has holes that you can completely see through. So this obviously needs to go all the way through, but these are now 8mm deep holes that I'm going to use threaded inserts for. So we're going to try out threaded inserts because threaded inserts will make disassembly of this part much easier. Honestly, it's not like this thing. Well, I remember having to take it apart a lot, but I don't remember why. I think I only had to take it apart because I redid the top plate. Anyways, the main annoyance of it though was indexing it. Indexing being the process of getting the holes to line up. So yeah, so I think what we want to do is actually do both of them. Right. So we're gonna need 8 of these. I think I only put in 1 in last time, but that's because I was sort of short on these things. But since I bought this kit, I'm sort of good. 2, 4, 6, 7. Okay. So let's get another one in here. Dude, buying the right tools is actually one of the biggest pro strats though of this whole thing. Wait, I need I need my notebook. So I don't scratch this. All right, I'm gonna fix the camera in a second. How is that? That's a little bit better. Okay. Okay, so now that it's sticking through, get it like this. Then you pull it back a little bit actually so that so it binds to the right spot. I mean, that's not going anywhere. The thing is, the forces that this takes are so minimal. That thing's not going anywhere. You can lift the whole thing. Okay. 2, 4, 5. One more. 6. Okay. So yeah, assembly is honestly, these do not need to be 5 mils. It's just I bound so much stuff to wall just because it made it easier, and it cut down on the number of. Oh shit! I just screwed into that. Let's do it on the paper. Honestly, I'm just gonna do 1. I think 1 is so enough. Okay, so now that it's here, you pull it back. Now it's flush, and then you can put it back in. It's not as strong, and it can rotate, but I can't be bothered with. I'm doing this the right way. I don't think I ever made a parameter for self-tapping clearance, but I think it's 0.5 mil because I'm pretty sure these holes are 1.5 and these self-tapping are M2s, so, you know. But yeah, indexing these is way better than indexing that gear because you get basically no visibility with that gear. Okay. Yeah, it's strong. Definitely not as strong as this. This you can feel it because you can tell that it rotates. Whatever. Whatever. Okay. The fact that there's this little cap here that spins is so chill. Okay. I wonder if YouTube sends a go live notifications because I know Twitch does. I'm gonna ask. I'll ask Ole later. Okay, so there we go. That's the first step. The second step is put the motor. So we gotta go get our motor, which means I need to go disconnect that one. So I will pan over there. Actually, I'll just bring the thing over here. How should I do this? Maybe like that. Okay. You can kind of see it. If I move all this. There we go. Now it's in the sun. All right, so we're gonna be taking this apart. So let's just get all the electronics off of here. Okay, now we need to get my Allen wrenches at my little metric. I think these are M3s. No, they're M4. Okay. And I'm sort of hoping to design the hopper today. We'll see if we can get to the hopper because we need to assemble everything. Then the real goal is to get this solenoid to be controlled. So for anyone that's remembering, we have this solenoid, and right now I tried, but I can't get it. So you're supposed to use a MOSFET to take the Pico's output, a digital pin output, and then control control a MOSFET that connects to a power supply to actually use this solenoid. And one thing that's surprising to me about solenoids, this thing draws 8 amps of current, which is pretty crazy. 8 amps at 12 volts. I mean, that's insane. Okay, so now we need to get my vise. Okay. Big vise and little vise. So how do we want to do this? We probably want to put the little one. So for those that don't know, the way you use a vise is it has this clamp, it has a spring, and it has a turning thing, which allows you to loosen, basically increase the distance between this clutch. So then you get it so that it's tight around your object. There we go. And now that it's loose, you can sort of just hold it and hand loosen it. Okay. Can you see me? You can kind of see me. Okay, now this thing can move freely. So, what we need to do is we need to get its top plate off. Okay, now if we push this through, now we have the top plate off. Okay, so now let's just keep taking things apart. Oh, I'm so excited to use these threaded inserts. This is going to be big for me. We need, oh. Actually, you know what I realized? Oh, hold on. what I realized is that so for this needs to be very strong, this thing that holds the motors, because these vibrate like crazy. Now the problem is these nuts and bolts keep falling out, which is really kind of bad because that means this thing could just come apart. And I'm wondering if I could use threaded inserts in addition to these nuts and bolts and maybe make it a little bit stronger. Where do we put that, Allen? I think this is the M3 one. It's such a pain getting these in here. Oh, it's going to be even more of a pain, actually, because I lowered it. This design might be no good. Where is it? If we take this, there's going to be no way of getting a... Maybe we'll put the bolt in from the bottom. Yeah. Oh, wait, here's what I do. I'm so dumb. Take off this first. Then it's easy to put these back on. Man, I have printed so many flywheels. So many flywheels. Okay, now we can use this Allen wrench to easily get to these. Maybe you can do it. Maybe it's going to be really annoying, though. What clearance was on that? That was not... What you really want is clearances to be about ratios, because as the size of the bolt goes down, or you want it to be the ratio of the size of the bolt and the 3D printer's nozzle diameter, I feel like, because these M3s are hard to get in there. But if you put... No, I don't know what I'm talking about. I'm just making crap up. All right, the drones have been freed. Okay. Um, Screwdriver. Screwdriver. Maybe another what on top? Wait, hold on. For some reason it has like a weird. Wait, I want to show chat. Wait, can you hear me? What's up, bro? Eduardo. Thanks for tuning in, bro. Maybe another support on top. Shit. It doesn't give me timestamps. Let me see if I can get timestamps. Oh, there we go. Timestamps. Was it 10? Oh, that was like 6 minutes ago. All right. Well, if you're still here, bro, thanks a lot. Okay. So yeah. So this piece here was the absolute bane of my existence because if you can see, there's two very small self-tapping screws on here, and they're impossible to line up with the gear underneath. There's just no index whatsoever. What I could do is I could have made them through hole, and then you could at least line it up with a light shining through. But even still, it's just like, I'm going to try these self-tapping things, and we're going to see how that goes. I'm very excited about that, honestly. Plus, it should make assembly generally easier. Okay, so now this is all taken apart, and it's all old parts. This is new, so we're going to leave this over here. Okay, now we need... all right, we might as well reclaim all of these self-tapping screws. So I spent a good amount of time, well, in the redesign, I've made a lot of things lower profile, and I think that might actually be a pain in the butt because oftentimes you need to get your hands underneath it so you can hold something tight. The other thing that I totally flubbed was, yeah, I made a really big mistake. I should probably reprint the bottom plate. Because the problem with the bottom plate is okay, so if you're trying to draw you draw a circle and you extrude it. Now you have the top of the bottom plate. Then you draw a circle on the bottom of the bottom plate and you make it some amount less than the you're working diametrically. You have to multiply by 2. Anyways, so the wall thickness is not right, which is very upsetting because the whole point of reprinting the bottom plate, which takes like 3 hours, is that I wanted it to be stronger because, and I'll show you in a second, that this plate, under the load of having a motor on it, gets totally warped. I don't know if you can see that from here, but it gets totally warped. So, huge issue. Okay, now we need an M5 jobby to take out the set screws of the first. And I forget if this part needed to be reprinted. I'm pretty sure that I changed the height of it. Okay. Oh yeah, and then we have some nuts in here. Okay. Old dumb part. Now support the motor from the bottom while you're taking this off. Okay, now the motor is out of this thing. Now we just want to... Man, the thing I spent the most time with on that new design was just getting these, was just getting the holes that go into the bottom plate to be tangent, or perpendicular. I spent so much time on that. But now it makes sense. You basically make a plane at an angle to, like, the XZ plane. Then you make an offset plane from that plane. And then you do a circular pattern, and then you circular pattern again. And that gives you basically the feature. And then the other pro strat from OnShape is that you don't do a circular part feature. That's not the way to do it. What you want to do is an assembly. Okay, so now this is completely taken apart. You can see just how mangled this thing really gets. You can see it's like a smushed pancake, and it's totally screwed up. So unfortunately, I think that actually this wall thickness is 2, and with this was supposed to be 5, but it's 2.5 because I made the inner diameter here. I made it 245 instead of 240. So anyways, I just did the math wrong, and that's kind of a big bummer because, you know, I don't know. Okay, so I'm gonna, let's see, clean off a little bit. Okay, wow, so just for reference, get this free. This is how many parts go into that. That's a lot of parts. Okay, so okay, so the very first thing I want to try actually. Okay, the very first thing I want to try is I'm going to use this soldering iron here. And I want to get, and I'm pretty sure, let's see if it's in my, M4 by 8 by 6. Okay. All right. Oh wait, this plate needs to go too. All right. So, I'm doing this for the very first time. But the idea is you take this, and you have these threaded inserts. M4 by 8 by 6. And so now this hole is slightly less than the diameter of this. And you can see that there's this word that people like to use called knurled. And it's KNURLED, knurled. And I don't know if you're supposed to put them... I think you're supposed to put it down like this. Wait, so I need 2 of them. Okay, so I'm sort of doing the assembly out of order here, but that's only because I'm excited. So here's what we do. You slot that in. Oh yeah, you slot that in and now you have an index. Okay, this thing is hot. So now you just... You're supposed to just be able to just push this in here. Oh yeah, it's going. Oh, it's going. Cool. So now we have these little threaded inserts. I'm going to get an M4 bolt here. And we're just going to see just how strong these things are. I really don't want to strip it, though. It's still hot. I think it'll do. So this is great. So let's just do the second one. Whoa, this thing got hot too. Wow, okay, so the heat transfer is no joke. You gotta be careful. You don't touch these things after they're in. Nice. So that's it for now. That worked really well. So now what I want to know is how easy is it to do this? I think this is going to be quite easy. So we got 8 down here, we got 5 here. So we probably want 12s? We probably want 12s. So yeah, so this is what we want. So we're going to just put this through here. Get a couple of turns on it. Okay. Oh yeah. That's the stuff. Now let's see. Oh, this is strong enough. Yeah, that's great. Threaded inserts, highly recommend. Cool. Wait, these are all mixed up. Okay. Oh, what you need to do with this part now is you need to really tighten it down before you put this on. So wait, do I have that in my assembly file? Use self-tapping to put, okay, you put the, fasten the motor. Put the small gear on the shaft and use set screws. Put mounting brackets onto the bottom plate. Put the BLDCs together with the flywheels. Okay. Okay, so yeah, that's what I said. Okay. Right, that's the only way to do it. Okay, what's next? So then now we can do that motor stuff later. Let's just put these on. So we need okay. Oh wait, these might be too long. No, they're good. But I mean, they are too long, but they're fine. Yeah, so the problem is when you need to take it off. Oh, and you know why these are too long is because okay, so in the previous design, this is a feature that I didn't include in this redesign, was that we need to increase the clearance on this. These aren't working out. Yeah, I didn't include the rotary, what are they called? Magnetic encoders. I didn't include that on here, but that made this thicker. There we go. Oh. Okay, so on shape fixes. Uh, the BLDC magnet needs at least a small hole in the motor. Yeah, so I didn't put a hole there. All right, that's fine. Okay, I am gonna tighten these down with the vise. Okay, so I think the pro strat way to deal with these vices is you go like this. You get it to where you want. You tighten it, then you loosen it, then you tighten it a little bit more. And now it's on there. And now I can use my Allen wrench to just really get it exactly how I want it. Okay. All right. So that's hopefully not going anywhere. Hopefully it's staying put. Oh, and I should add a note here. When doing this, make sure you put the cables of the BLDC on the same side. Since the design is symmetrical, I don't have to actually specify a side. Intro to Nuts and Bolts 101, the nuts and bolts of nuts and bolts. Hi everyone, welcome to Nuts and Bolts 101. This is the nuts and bolts of nuts and bolts. During the synthesizer project, go check my channel for that. My favorite tool was the Dremel tool. I think my favorite tool is the vice grip for this. Oh, I meant to look up my. Oh, guys, I forgot to say, you are no longer am I a neat pilled incel, live streaming to absolutely no one on the internet. I am now a net pill, not. Wait, I'm not in employment or training. Net pilled. I am being educated at the moment. Your boy is going to school. Oh, I don't remember how to tighten this one down. Okay. That's good enough for me. So now the next step is get some coffee. Okay. Back to assembly. What do we need to do now? We need to... Okay, let's put the... Okay, so we have our flywheels. Wait, is my... Yeah, you can see this. Okay. So now, these things use what's called a collet. A collet is a very cool design. I like them a lot. If you can see there's slits on here that allow it to deform under tension. So, or compression rather. So when it gets compressed, it locks down onto the shaft of the motor. And this is how you keep things tight. So I have this, which allows me to put this on here like that. Okay, so this goes down. All right. So to put this together, again, use the vise. Loosen it a bunch. It need to be way looser than that. Okay, then you tighten it to where it's touching both faces. Then you tighten it a little bit more. And now it's good to go. And then you can just tighten it down really good, because this is the thing that needs to... This is what keeps people safe, is this bolt here, or this nut here. So you really don't want to play around with this one. Okay. You might not be able to see this, but they're slightly angled, and that's because I don't have... There's a small magnet under these, and they, whatever. There's a small magnet, it's causing an interference. Okay. What is the next step of assembly? The next step of assembly... Oh. Let me think about this. If we put the bolts through here, tighten that, then we put this down. No, I think that's the way we want to do it. Okay, wait, actually, so... Yeah, I'm switching it around. Because with a vise, it's not that hard to get in there. But it's going to be impossible to get... okay, so we need to do... So we have this... Oops. So we have that gear. We just need our motor. Okay, so this is a NEMA 17 stepper motor. And we just... Oh, I don't like how these things rotate, to be honest. But whatever. Okay, so this slots in there really nicely. We just need to get our, what, M3s? I don't remember what size they are. It's this. One. Okay, I seem to have lost one. I was really hoping to avoid losing parts, but I guess it's inevitable. So this is an M, whatever, three is enough. Oh no, did I project these? I don't remember how I did this. Whatever. It's fine. So we want the cable to be facing outward. I feel like somehow yeah, so small hole in the motor mount, but also okay. Whatever. This motor one. Okay, so this was a total fail. For somehow the well, they don't have enough clearance, but they seem misaligned. So both the BLDC to uh, motor mount hole spacing and the NEMA hole spacing seems too tight and too close together. That's really annoying, but whatever. It's fine. He's fine, buddy. Yeah, it's fine. Yeah, this is just not gonna work. Okay. So now we want the gear, which is, where's that small gear? Here it is. So this small gear has a hub in it, and you put nuts in it, and I'm pretty sure. I am pretty sure. Okay, it's M4. Mm. Damn it. We're gonna need to print another one of these. I think I made this exact or just slightly too. Oh. Damn it. Alright, should I just try this to get it out? This seemed to work pretty well. Turn on the soldering iron, touch that thing. That shaft must be made out of steel. What is steel's normal melting temperature? It's not a Roomba. It's not gonna move like that, but it's gonna shoot like Nerf darts. Um, Steel melting temperature. Oh yeah, it's really high. So we should be able to. Okay, so this gear just does not come off. So if I do this, and I try to lift this up. I don't know how long I'm gonna have to wait. The thing is, I'm only touching the tip, so the heat transfer is slow. Damn, this sucks. Can't believe I did that. Well, wait, is it working? There we go. Oh, don't want to breathe that in. Ugh. Okay, cool. So we need to reprint that. So I'm gonna go to this. Okay, so we have 10 minutes left on the solenoid holder. We need to reprint that gear with just slightly more clearance. Okay. Slightly more clearance, no problem. Should I do it again? No, that's stupid. Why would I do that? Okay. So I'm also going to take the drill and just give me a little bit more clearance so I can mount this. But we need to fix it in CAD. But I don't understand how that even happened. How did we get those circles in the first place? Okay, so first the gear. So the gear is going to be in the bottom plate or no? No, it's not. Wait, in the full assembly? We have the gear. So that means in bottom assembly. Okay, so here we need to open this. Edit in context. Oh, wait. Stepper. Move to new subassembly. Copy. Switch. That's what I'm looking for. Switch. Okay, so we have this. And now hex flats clearance, but we don't have a oh, we have this. Okay. It's probably not that. .2. Stepper shaft diameter. Stepper shaft gear clearance. Stepper shaft gear clearance. Where is that? Is that in my? Okay, let's make it 0.4. Okay, and then we want to go to the bottom plate. Okay, how much can people see? Hopefully, okay. So now so let's turn off planes. Where did these features come from? Okay, so wait, so where did this number come from? Mounting hole diameter, where is that? Is that up here? Yeah, let's open up Fusion. What do I have in Fusion? I'm sorry, my bad. Oh. I'm almost positive it's 15, but I feel like I should make it. Oh, wait, you know what I could be? It could be that Nah, it's to the center. I was thinking maybe I made it like. No, but then it would be even off by a lot more. I might just make it stepper. Stepper hole. Let's make this 4.4. Because the head of this is. I think I have this as a parameter or whatever. It's 5.2. So yeah, so we're good. That should solve that problem. And then in the motor mount, this isn't the part of the top assembly. Mirror. Wait, which side has the mirror? Oh. Actually, these ones seem right. I could get a bolt through there. But I do want to make the clearance slightly bigger. So we put 3.4 for M3 hole. Okay. I forget how big the magnets are. I could go get one. Let's just make it 5.5 and the indent like 3. Wait. We want to do yes, but then we want to move this here. And then in this mirror. Okay, there we go. Cool. So we fixed the 3 problems so far that I've had with the assembly, which is nice. There should be a small divot under there for the magnet, which I glued on, by the way, so you don't actually need that if um okay. So what's the next part of the assembly? Oh, we need to go get this thing off the printer. Right, it's okay, so it's finishing right now. And then we need to print another small gear. And then we need to drill into this thing. So I'm gonna go get the drill, and I'm gonna go get that. And we are gonna get a where are my drill bits? We're gonna use a 4, I think. And hopefully we don't crack it. That's the biggest fear, is that's why a drill press is nice, because it doesn't bind as much, especially if it's high speed. The problem is I go slow speed and then it binds. I go slow speed because I'm holding it. I need to clamp it down, I think. Maybe we'll do this the right way just so that I can know what it's like to do it the right way. So I'm going to get a couple clamps. I'm going to just clamp it like this. And then I'm going to drill. Oh, I forgot to get the clamps. Damn. Okay. I got distracted. So here is the this thing that holds the solenoid. This loft isn't right, man. Something is seriously wrong here. So if you can see what's going wrong, if you drop the ball down, it doesn't sink far enough down. Wait. That on the, hold on, can I move this stupid heart button? This freaking emoji react is blocking that on the text to code. Okay, I don't know. I don't even know what you're talking about. But oh, this is so annoying because I thought I had gotten that arc perfect in Fusion, and it's the same exact parameters. So, okay, so let's just reprint the small gear. I'll do the bug fix on this solenoid thing. I'm kind of pissed off about that, but whatever. So now we need to go to on shape. We need to select this, switch to small gear, export. Oh, wait. I don't know if it might not have applied it. That would be so annoying if I forgot to like confirm the sketch, even though I changed the parameter and then it like didn't have the right clearance. Yeah, we're gonna have to figure out what's going on with that because it does look different. Like right when I printed it out, I could just sort of tell the geometry felt a little different. The easiest thing to do would just be make that diameter bigger. Probably. If we make both those diameters bigger, then we okay, I need the clamps now. We'll get the clamps, we'll make those holes bigger. Bro, assembly actually kind of stinks. Designing is so much more fun. Okay. Maybe I can vent acetone vapor through that opening? Which opening? Oh, you're talking about the this solenoid, the thing that they put the ball into. Yeah, I have heard that acetone will melt PLA. I've never tried that though. That's a pretty good idea. The thing is, I want to know what chemical reaction it is because I would want to take the proper precautions. But yeah, I mean, that would be a pretty nice way to just not have to spend 2 hours to reprint this. Obviously, still need to fix it in CAD, but in any case. Okay. Okay, so we got 2 clamps. Let's do this. And you tighten it. And actually, I want to do it like this on the wall so that it's strong. Okay, and here. Okay, now our drill bit. Okay, that's 4 millimeters. Let's see. Yeah, I feel like let me take my calipers out because I feel like the distance between these center holes is not 30. I feel like it's like 31 or 2. Yeah, man. I don't know. I feel like the design in okay, so I'm probably going to do it with the 4.5 because it still doesn't look the problem is the 4.5 then you really don't have that much clearance cuz the socket head is a maximum diameter of 5.2. But in any case, we're going to go to the is it the bottom plate? And we're going to go back to this sketch. And is this just a blank 15? I'm going to make this a parameter. I feel like that's always a good idea. This is going to be stepper, shaft, center, vertical, vertical, dist. Oh my gosh, my computer is dying, bro. I think it's the heat, but it's also like, oh wait. Oh. Damn, this thing is dead, man. What the heck? And we are going to make this 15.5. And now we go back to bottom plate. Stepper shaft. Okay. That should fix a lot of my issues. I'm actually gonna watch a video about that, dude. Let's see. Um, I like this made with layers guy, actually. Do I have my desktop audio on?
What's up everyone, Tom
Yo, am I
here,
lagging?
and at this point it can be considered pretty much common knowledge that you can smooth out the layer lines of 3D printed parts made from ABS, HIPs, and the likes with an acetone vapor bath. But I was told that this should also work on some types of PLA like the ones from dust filament. I was intrigued because the common understanding is that the PLA shouldn't be affected by acetone at all. But I mean, I've got plenty of 3D printed parts laying around, so why not just try it out? So acetone is actually pretty cheap to get hold of. This 1 liter bottle cost me just €2.99, and I use it liberally for things like cleaning, paint stripping, and anything that's similar to that. Now, as a first step, just to try and see if acetone had any effect on PLA at all, I decided just to dunk a piece in the acetone liquid. And after leaving it in there for a few seconds, it started to get really sticky and gooey on the surface, and you could feel that layer coming off when you were rubbing it with your fingers. Parts that are dunked in acetone like this for an extended amount of time do get smoothed out, but they do lose a lot of their stiffness, and I also think they lose a lot of their strength, so that's not really recommended. But it got me thinking, before we even get into the acetone vapor smoothing part.
So the lack of strength isn't an issue here because there's just basically no load on it. I mean, you're holding like I haven't weighed these, but these are probably, what, like 20 grams? I don't even know. They're so light. They're just all air. This is so funny. This feature, just this little hole, has been such a big issue because it's attached to so much. It's so funny, like, you can just always come up with the analog to programming. It's like, do you make one big function, or do you how much do you modularize and how much do you abstract? Because basically, it'd be hugely advantageous to decouple the feature of this hole from this part. Because it takes so many iterations to get the geometry right. And I think I did a stream where I actually, I don't know if I did that on stream, but maybe I did, where in Fusion I started with just the hole, printed that out, then I added the solenoid holder walls so that I could mount onto it, just to test that I could push it through. And then only after all of that did I actually add the whole stand that mounts onto the thing. All right, so let's just okay. One more time. I'm not gonna clamp it. Okay. So let's see if it fits in now. Okay. We can probably get 2 in. 2 is good enough. 1 is definitely not good enough, though. You can see these socket heads are actually, it's actually sinking into it. It's not great, but it's honestly fine. Okay, great. So how long is that thing gonna take to print? 6 more minutes. So what's next on the assembly is we're sort of just waiting on that gear. I guess in the meantime, I can fix this geometry. Where's the solenoid, by the way? Oh, here it is. I don't know, it feels like I'm gonna go back to okay. I'm gonna go back to I mean, I'm almost positive I defined it as a tangent arc. Oh. This actually isn't tangent, and I bet if we were to click on both of these and try to apply tangency, yeah. Oh, I remember this. So what I did in the other design, so this is the center of this thing, because the distance between, that's so funny, dude. I didn't even think about that. So the distance between this point and, oh wait. Wait, let's just do... Right, so that's 17.5. Because this is... Wow. But I kind of like it being tangent on both sides. But it's... That's so funny, I never noticed it. So, whatever. But I don't want to print the whole thing, so let's just start a new part. Okay, so if we're going to start a new part, we can turn this off. All right, let me go get the small gear and just make sure that it works. Oh, okay. Yeah, I'll go get it. Where's the big bolt? Actually? Right here. Ten was kind of aggressive. I should have measured this thing. I was too lazy to take it apart. Okay. So yeah, fine. So I'm gonna start a new part then, where I rebuild. I rebuild this part. So first off, right. Right, so this is actually 17.5. But then if we enter this, we fail. Right. Right. Because see here, see we have all of this weird... Wow, that millimeter and a half looks so significant here. I knew this thing looked thinner. Let me look at the old one. Where's the old one? It's literally such a small thing. But I think that's literally the only difference. Is you make it tangent up here. It doesn't need to be tangent down there. And then it falls in. I don't know if you can see that. Okay. It's so crazy how consequential tiny little, well, what you think are tiny. Like, I was just like, oh yeah, tangency is what I wanted. Um, okay. Nice. Yeah, I don't know why I sort of insisted on having tighter tolerances there. It's like it's not a. It's like the set screw is gonna do it. And 12s are gonna work. So we just need the nuts. We need M4 nuts. We need 2 of them. Is there a button to toggle visibility? Where's my mouse? It probably is. Okay, so what you do for assembling this is you take the flats and you drop the flats in. And then this is dimensioned. Oh, wait. Oh no, I think I have this on the default configuration. I'm pretty sure M5s are bad. Bad news bears. Wait, so what I should have done is I should have done the configuration. Okay, so we're gonna have to go back through and we're gonna have to print this yet again because I didn't know how configurations work. Well, it fits perfectly with an M5 nut, so we need to print again. And I believe that. Okay, so wait, how do I find all my configurations? Let's turn this off again. Um, oh, it's right here. Okay. Okay, well, and while we're doing that, we might as well fix the solenoid feed. No, I actually don't want to do that because then I have to wait for that to so we're just gonna print this again. So these guys, well, I'm not gonna throw them. See if I care. All right. Jeez Louise, bro. Okay. I should have Should have thought about that. Okay, so we just have to wait 20 minutes basically because we can't assemble this. So I might as well fix this thing. Okay, let me take a piss and then I'll fix this thing. Okay, I actually want to test and see that the M5 configuration of the thing actually doesn't work because I'm not convinced that it doesn't. Well, I just don't remember really. So let's put the two M5 nuts in, and then we really only need a 12 mil M5 by 12. Push it down in there. Well, whatever. Okay, so M5 by 12. That should be enough. Let me just verify that. Like placing them in the middle was such a good idea. Placing the set screw holes in the middle. I forget. I'm pretty sure. Yeah, it's the middle of the hub depth. So. Oh, you know what? This is gonna do. This is gonna do just fine, I think. Is this the M5 one? I don't think so. M5s are big boys. Big, strong, big, strong boy. Oh, there it is. Okay. So we actually didn't need to print that. That's great that we can use M5s because M5s match the shaft diameter. We literally only have like a mil of clearance towards the pillar, but a mil is all you need. Milli vanilla on the really. Okay, cool. So now we are ready to put this. So wait, which order are we doing this? First, we're putting the top plate on, then we're putting the thing on. So this goes here. Then we put this in. And we need to change that. I mean, we need to change all of this, but this is 6.2. Let's just go in. Surely there is a variable for it. Center bolt diam. I love that you just go and change a number and then your whole assembly is now more correct. That hole is now 7. So cool. So now we need the 2 big nuts. All right. So now why is the friction so high? No, that center bolt diameter is gonna screw me. I need to go look for a bigger bolt. Otherwise, we have to reprint all of the... Dude, it's crazy. Just a tiny little thing throws the whole design. I mean, it just sets you back. Like, I was just like, I'm lazy. I don't want to disassemble right now. Disassemble the thing that we did just now and measure that bolt. And now we're totally screwed. Well, we're not screwed, but I'm just saying, like, it's just such a kink in the whole assembly process. We need like a 9 millimeter bolt. I'm gonna take the calipers and we're just gonna go look. And it needs to be at least what, 5 plus 19. Wait, no. What is that? I think no, it's what is that hub? If we go to the top assembly, wait, that's 6? Okay. So that means 6 plus 19 is 25, right? No, wait, don't we have a parameter that actually defines this? Like top of bottom plate to top plate, no. Is it? Should we just search for 25? It should be 25. Oh, top bottom plate distance. Okay. I knew it was at the beginning. Yeah, so okay, so 25. So we need, and then plus, jeez, This whole thing is actually just like really dumb because these are guaranteed to come loose. I mean, nylock would sort of work. I don't know if I'm ready to commit to nylock. Whatever. Okay, whatever. We need to wait, what are we even doing? I totally lost track trying to fix that stupid pillar. I was gonna do something. Okay, whatever. It's gonna be 5 plus 30, 30 plus 2 of these. All right, so at least 35 mil long and like 9. I don't know. Maybe we'll find something. Oh wait, actually, I might have just what I need. No, this only goes up to M8 by 20. M8 by 20 is gonna be too short. Okay, so I couldn't find a bolt that was any better than this. So I think I have to design my way out of this mess. So the plan is okay, all right, I got it. So the plan is it's going to be a hollow cylinder with a little right angle at the top so that you can slide this over it. It'll drop down in. What is the flats distance on this thing? It's probably in inches. 0.42. I don't even know what that means. All right, 11. And the whack. The whack is 12. So it's got to be less than 12. And what did I say is 10.5 or something? 11. 11 and 12. So we need to make okay. All right, so new part studio. And this is going to be called Lazy Dumbass Forgets to Measure. Okay, so you can turn this off. All right, lazy dumbass forgets to measure. So this okay, so let's just make a Q of 10. Okay. So we want the ID to be 7. Oops. Oh, wait, what? Oh yeah, you have to do, dude. When it's yellow like this, you should be able to type. Where's the dimension on this? Oh, there it is. Wait, what? How did that get all the way out there? Okay. So now, and we could actually make this, okay, so now we need this to be, well, what is just the length of the bolt? Well, we don't want to make it run the entire length of the bolt because then it covers the threads. So how much is sticking out? we want it to go to. Okay, so it's gonna be. I think it's gonna be 35. Top. Oh wait. Top plate to bottom plate. This is going to be equal to 2 times wall plus top bottom plate distance. Dude, why does it always mess that up? Okay. Now on here, we just need oh god. So ridiculous. What did I say it needs to be? Wait, no, it doesn't need to be smaller than the whack. It could be arbitrary. So just make it 15. So now we want to take this profile and this profile, and we just want to extrude it by 5. But then we lose 5 mils. Where are the 2 nuts? Where did I put those things? There's one. There's the other. Okay. We can just make it 3. Okay, cool. So this is this stupid hacky fix. So is ours... Okay, so this is done. So I'm going to go get that. We can export this. Yeah, I didn't forget. I was just deliberately lazy. All right. Okay. But the real problem is that I don't actually have... I don't really have... the hell is a thrust bearing? Dude, I really have to make this thing with... Design takes so long. I mean, it's challenging. For now, let's just put on the oh, come on, man. That's not that big of a deal. All right. We'll just have to do it for these two. Well, my main worry is when you bolt into this thing, that's when it's going to get, that's what's going to crack. I mean, at least we don't have to drill into it, because drilling totally messed it up, but, another bug. Oh my gosh. Did I really use the wrong angle? I don't think I ever updated the angle. Oh my goodness. Okay, so we got to fix the bracket design. Well, and we have to ensure that the so okay, so here's what the problem is. These holes are not lined up with, so if I take all this out. Oh, wait, let me just take one out. These holes aren't anywhere near where these are. They're actually, the outer edge, the far edge of them lies onto the, oh boy. Okay, let's just fix it. It's not that big of a deal. So, this is the bottom plate assembly. So, okay, so here, if I actually just look on the front, wait, what? I'm so confused. Did I just, wait, wait, what the heck just happened? Parallel this 85. Maybe I just didn't update the STL. No, this is 85. And that's 65. I'm so confused. If I just print out these brackets, will it work? Okay, whatever. I'm adding it to a to-do list. Two of them is gonna be fine enough. We did this. Okay, oh, did we actually increase the clearance there? I think we did. I think, yeah. What we need to do is fix the bracket, the bottom plate mounting bracket. The holes don't line up. That stinks. And I said earlier, I spent so much time trying to get this right. All right. Well, at least it's on. Do the other one. Oh, 10 millimeters. It will be fine. Wait, let's see what time it is. It's only noon. The hell? Here we go. Okay. There's so much play. The backlash is like 5 mils. No, it's 6 mils because it's the difference with no, it's like 8 mils. Or mil I keep saying mils, but mils I think means I think it means 1,000th of an inch. But when I mean mils, I mean millimeters. But anyways, it's like 8 millimeters of play. That is totally crazy. Okay, so let's check out fritzing then. Oh yeah, wait, so I didn't have my